So welcome back again. Now we are going to a new section. 8.4. We have three great ideas. We have trigonometric substitution. Here's the trigonometric and here's substitution. Silent, please. And for that purpose, we have three types of the examples. All of them are the same, but we make a difference by what? By thank you. Turn off all. Thank you very much. We make them the different by the letting which we have. For example, if I have one of, or if I have, let's see, if I have something like that, integral of a squared plus x squared means that if I have 5 we have 4 plus x squared dx. Understood? So how we solve that one? We cannot eliminate, we cannot do anything with it. As x is not sign, we cannot eliminate square root. So how we do, how's the method that I'm going to do it? You look at the examples before I'm going to solve anything. Look at the examples. Look at here. And look at that example again. Second example. It's generally solve it. Look at that example. Okay. So how we solve that one? And again, example number 3. Okay, or number 4 here. And such examples like that. So how we solve that examples together? So all formula, look at again, we have what? We have 25x squared minus 4, and there is no formula for it. We cannot solve this one by formula. Okay. And again, we have x squared here. So how we eliminate this x? And how we solve that? I know without this x, I can say is a sine inverse, right? Because without this x squared, that one is formula of sine inverse in 8.1. But now I have x squared. So how we deal with that one? We are not going to throw it out. It's kafir, it's taboo. So how we solve that one? That's the idea that I'm going to cover today with that one. So now here's the idea and how we change the steps. Very important. After the steps, you know how to solve that one. So we have many instruction here, many instruction here. 1, 2, 3, and look at the instruction is about 1, 2, 3. We have 3 types. Then we are going to apply this instruction, and also we have a 3 right triangles. We need all this information together, then we can solve such an example like that. So here we are. I'm going directly going to the example, and I will let you know how to solve it. So 8.4, trigonometric substitution. If you have this formula, as you know, a squared minus x squared, you say that x is equal to a sine of theta. You'll bring theta instead of x, you change x to the theta. That's the first. So before you are going to start to solve anything, you should recognize it's a sine or tan or is second. So I'm going to change x to sine theta or cos tan theta or what? Secant of theta. Understood? That's the first idea. So in case, if my example is like that, x 4 plus x squared. So because the plus, my mind, and because I have a square root, so my mind will be on that one. If I have a minus x, it will be like that, like that. That's why I say let x be what? A sine theta. What's a? A is air. So I'm going to compare that one with the formula a squared plus x squared. So that's why I say a equal to 4 to 2. Understood? And I say x is equal to a, means that 2, sine or tan, I say tan theta. What's theta? It's nothing. Theta is angle. Understood, dear? This is the first. We need many steps, do not forget. But one by one is easier, if you understand. Do you have any question? If I change that one to minus, do you know how to deal with it? We can solve this example, if I change to minus, by two methods. First of all, first an easier one, sine inverse. Forget about the sine inverse. If I'm going to solve by this method, so how I solve? I say what? I say a is equal to what? Sine of theta, okay? A is equal to sine of theta. Do you have any question about the first step? Hello? You get the idea, dears? Good. So A is equal to sine of theta. That's the first. The second step. So I changed my example, okay, to be easier. So we say that we are comparing with minus. So I have the sine. So our example can be by sine x. Now, the second is going to make a triangle, right triangle with theta. So here's the right triangle, and I have a theta. So tell me about which side. That one is equal to what? That one is equal to what? And that one is equal to what? Yalla, tell me. The side of this triangle. Do you mean the sine and cosine? No, the sine and cosine. The values, yeah. So from the first, I say x is equal to what? 2 sine of theta. So sine of theta is equal to what? X over 2. And sine is equal to what? Opposite? Hypo, right? You got now, right? Understood. So we say opposite over hypotenuse, right? So, sorry, hypotenuse. So we have what? We have x over 2. We have x over 2. Understood. So tell me about the third part. Is equal to what? I see is equal to the given 4 minus x squared. How? Which rule? Yes, you are right. But how we bring the third part? Trigonometric functions give me two sides. Yes. Okay. Pythagorean rules. Why? Because I have a right triangles. Yeah, Pythagoras. So the so we have this part, right? That part. So we add them. I will get that one. Because in the right triangle, A, B, C, We say a square plus b square is equal to c square. That's why. So I have AC, I can get, sorry, BC, I'll get A. Or if I have AB, I'll get C and vice versa. Understood? So that's why. This is the second. Do not forget that one. We use that in the last step, final step. So this is the second. The third, I'm going to change. Or you can say we find d theta. So I say dx is equal to what? Or finding dx. I say dx equal to 2 sine theta. So dx equal to what? Derivative. Derivative of sine cosine theta d theta. Do you have any question about the third, second, first step? Hello? Clear. But you need practice, right? I know. So the fourth step, change the integral from x to theta. How? I say we have dx. I remember I changed the example to that, right? So I say is equal to, okay, square root 4 minus, right? Now, dx, it was what? Dx in the third step. So how about x squared is equal to what? From the first step. Am I right? From the first step, any step that we mentioned, we see that one is equal. So from here, I know x squared is equal to 4 sine square of theta, both sides square, right? Understood here? So that's why I got what here? I got instead of x, I got what? 4x square. Understood? Hello? And be sure that this integral, the last one, d theta, is very, very easy. You saw that one many times. How? I see is equal to 2 cosine theta d theta. I see that one equal to 2, 1 minus sine square of theta. Am I right? I brought 4 and I bring it to out. Understood? Or at least you can write down like that. Now it's clear, right? And square root of 4 is equal to what? 2. So I'm going to bring it to out. You got it now? Now tell me about 1 minus sine square is equal to what? So cosine square, right? And you know cosine square with square root. Am I right? And you know, that's why I say it's easy. You got what? Do you have any question? An integral of d theta is equal to what? Just theta plus c, you can say theta plus c, right? That's the solution. But do not forget about that one. Last part, when you solve the integral with theta, you solve, there is no integral. The fifth step is what? Changing theta or result of theta again to x. For example, if you have sine theta, change it to something x. Understood what I mean? Now, in my example, from that one, I got theta plus c. So how I change the theta to x? From the first step or from the triangle? So we are going to use the first step or the triangle, do not forget. So first step, it was what? X is equal to 2 sine theta, right? So we say sine theta is equal to what? So theta is equal to what? Understood. So my answer of the integral will be what? Sine inverse of x plus. Understood? Yes. Okay. Yes, the same. From here? From here? Uh-huh. You want to say we have a derivative of denominator in up? No, we don't have the derivative of denominator in up. Derivative of that one is hard. When I say hard, I mean derivative will be like that. I don't know. -2 sine cosine. There's many things. So careful. Any idea, any question? So we are going to solve the lectures one. The real example that they give us. That was the extra example. Now I'm going to solve that one. We have dx, yalla, be with me kindly, x squared. So I say first step, x is equal to what? 2 tan of theta. Am I right? Second step, it was what? Tan theta is equal to what? X over 2. So tell me about the triangle. Yalla. Khaira. Ama theta leriye. Theta is in here, not in the up. Yalla. Right? So x over 2. Am I right? So here will be what? 4 plus x squared by Pythagorean or by that we have. Now the third step was what? Yalla khaira. Quick. Dx is equal to what? The fourth step. Am I right? Yalla jamaat. Dx 4 plus x squared will be changed to what? Number is number. I am sure. Dx is what? 2 secant square theta d theta. How about that one? 4 tan square of theta. Am I right? Hello? Yeah. Good. And I'll get what? Quick. Okay. 2 secant square of theta d theta. That one will be 1 plus tan square theta. And I know 1 plus tan square theta is equal to what? Second. Thank you. So it will be secant from here to there. So secant square theta over secant of theta. And you know, I'll get what? And you know, in Cal 1, secant theta is equal to what? That's why I told you 8.1 is basic. Use many times. So fifth one, am I right? Yalla, is equal to ln of plus c. Yalla. Secant theta is equal to what? Actually, I don't know. Also, I'm not sure about this because I told you should go back to the first or the second step. So I have x 2 4 x squared. Am I right? Now second is equal to what? 1 over cosine, right? So cosine is equal to what? Here, there. So I say there, here. So I have what? 4x squared over 2. Am I right? Understood or not? Did you get? Really? Shall I repeat it? No, you got it. So we say cosine is equal to, because you are recording that we such nice things here. I want to find second. I don't know how. Look, so I say second of theta is equal to 1. I don't know. I'm going to change it to the cosine of theta. I say cosine is equal to 2 over 4 plus x squared. Now, 1 over cosine, yeah, it will be what? It will be second, right? So that's why we say 4 plus x squared over 2. Now, here, second of theta is equal to what? 4 plus x squared over 2 plus tan of theta is equal to what? I know tan from the first step. Tan is like that. So tan equal to x over 2. Nothing to do it. It's easy. You got it? It wasn't hard, but need actually work and work. Okay. Now, forget about example 2. It's just comparing this rule with that rule. So you don't need to take time with what? With that one. So example number 3. Can you do it? Do you have any idea? We have x squared, x squared dx. The important thing, that formula, we have 9 minus x squared. Am I right? So I told you we don't have x squared, a sine inverse. But now I have sine x squared. So how we solve that one? Yalla. Quick. Which formula? Sine, tan, cosine. Sine. So I say x is equal to 3 sine of theta. Second, sine of theta will be x over 3. So triangle theta. Yalla. They x over 3. So here will be 9 minus x squared. Am I right? Without changing, without thinking about, I know. The third step, dx is equal to 3 cosine theta d theta. You know how. From the first step. Now, 4, change x to theta. So I have, we have a problem here. Look, we have x squared dx 9 minus x squared. Pay attention for that step. So what's going on? I have 9 minus 9 sine square of theta. Am I right? Okay. So x squared is equal to what? Again, 9 sine square of theta. Am I right? And how about dx is equal to 3 cosine theta d theta. We change also these x squared to that one. So there is an extra idea, extra things here. Now I'm not eliminating anything. So from the numerator, I will get what? Cosine theta. Am I right? How? Can you tell me how? I skip 2 steps. So I'll get 3, 1 minus sine square. 1 minus sine square, cosine square. Cosine square and cosine. So I'll get that one. And here 9 sine square theta, 3 cosine theta, d theta. And you know, cancel. So it remains, yeah, you're right, 9 what? Am I right? Why I changed to that one? I don't know. Go check in 8.1. Because we say many that also in 8.3, right? Sorry, 8.2. We use that one. So I'll get what? 9 over 2 theta minus 9 over 2 sine of 2 theta over 2 plus c. How? 1 over 2 integral, it will be theta, and I separate that one. Do you have any question? Number 5, I have what? Theta 2 x. So 9 over 2 theta, it was what? We say x is equal to 3 sine theta, right? So theta will be what? Sine inverse x over 3. Understood? Minus 9 over 4 a sine 2 theta plus c. Why I didn't change sine 2 theta right now directly? Why? Is not. We have 2. So I cannot say I am going to multiply there by 2, right? It's kufr. Why? Because that one's angle, I told you. And that one's number. So how we change? We should use this property. Sine of 2a is equal to 2 sine a cosine a. You remember that one. Now I have sine and cosine a, so it's easy. So I say sine of theta, 2 theta, is equal to 2 sine theta cosine theta. And I know sine theta is equal to what? I'm at 2. We see that before. We see that x is equal to 3 sine of theta, right? So sine of theta is equal to what? X over 3. How about cosine of theta is equal to what? Three over x. Why? I don't know. I should go back to what? Triangle. If you don't know, triangle. So cosine is equal to that one over that one. Am I right? Yes, you are right. 9 minus x over 3. So here we are. 9 minus x squared over 3. Now, substitute that one. My integral will be 9 over 2 sine inverse plus 9 over 4 sine of theta, 2 sine of theta cosine of theta plus c, and go multiply these numbers. You'll get the result. Look at here quickly. You'll see 9 sine inverse and these all together. Understood, dear? Easy? Good. I'm going to leave that one as a homework for you. And there's a little bit change, not idea, change here. That formula is like what? A sine or cosine or what? Secant. We have a variable minus number. So you have a secant of theta. So how we change, how we build a and theta, that's very important. Look at here. X is equal to a. So how we change a, how we get a? Because I should change that one from 25 x squared minus 4 to such formula to be x squared minus something squared. So I'm going to take 25 as a common. So I'll get 4 over 25. So that's why a will be what? We say x is equal to, now equal to, here's a 2 over 5. Then secant of theta. You got it or not? I don't see any sign of understanding. So no net, right? You disconnected. Understood or not? No, they say no. Okay. Look at dears. I have integral dx 25x squared minus 4. The formula is like that. Just compare with the formula. We say x squared minus a squared. Understood? There is no number with x, right? So we should make this coefficient to be 1. Now you got. How we get that one to get the coefficient? I'm going to take 25 from x to powers 2. Understood? We took out. So that 4 will be what? Over 25, right? Understood? Then I'm going to bring that one to out. This one will be 5. Now I have what? I have 1 over 5 dx x squared minus 4 over 25. Now you got it, right? So I say x is equal to what? I say a second of theta. Where's a? A squared is equal to 4 over 25. So a will be 2 over 5. That's why we say 2 over 5 second of theta dx. That's all idea that I said. We have an extra note. So kindly do not forget. Look, here's another idea. So careful, read it at home, and you'll get the result. The same theta, x, triangle, right angle, okay? But there's a something here. There's something. That's the first idea. And that one, second idea with the second step. Otherwise, the rest are equal, the rest, the same. That's all about 8.4. So do not forget about to study well. Stopping the recording now. Stop the record.